When we're dealing with exponents, we want to identify the base as the thing being taken to a power, and the exponent as the power it's being taken to. So for part A, if I was looking for the base is 2, and the exponent is the power that 2 is being taken to, in this case the third power. For part B, the base would be y, and the exponent would be 5. For part C, don't get confused by this 4.89. That 4.89 is a coefficient because that third power only applies to the x, it doesn't apply to that 4.89. For that reason, the base is just x, and the exponent or power it's being taken to is 3. As opposed to part D. In part D, I have 4.89x all being taken to the third power. Since it's all being taken to the third power, I can write it as base equals 4.89x and exponent equals 3. So there's a key distinction between this and this. Specifically, that exponent only applies to what it's right next to, unless it's around something that's all in parentheses. For simplifying the expression, we're going to be using the different rules that we learned in this section. The rule we learned for same base when they're being multiplied like this is we add the exponents. So this becomes x to the 2 plus 5, which is x to the 7th. Same idea for part B. The only thing is I can only combine things with the same base. So this x to the third and this x to the second have the same base and can be combined. This y to the 6th and this understood y to the 1st have the same base and can be combined. That's why it becomes x to the 3 plus 2, y to the 6 plus 1, which gives me x to the 5th, y to the 7th. But I can't do anything about combining the x and the y because they aren't the same base. When I look at division of bases, if it's the same base, I take the power on top minus the power on bottom. So in this case on top, I've got the 10th power, on bottom I've got the 4th. That's why the result is x to the 6th power. In part D, again, I need to make sure that I'm keeping track of x's separately from y's. They have to be the same base to use these rules. So for the x's, I have 5 on top and understood 1 on bottom, so it becomes 5 minus 1. For the y's, I have 9 on top, 4 on bottom, so it becomes 9 minus 4. 5 minus 1 is 4. 9 minus 4 is 5. So I get to my final answer, x to the 4th, y to the 5th. For part E, this is where I'm taking a power to another power. So unlike part A, where it was 2 bases with different exponents being multiplied, this isn't a separate x to the 4th that's being multiplied by this x squared. This is saying take the x squared that's already there and then now take it to a new power of 4. When it's power to a power like this, we multiply. So it becomes x to the 2 times 4, which is really x to the 8th. Here, when I have an expression in the middle all being taken to a power, I can see this as each individual part being taken to that power. So this becomes 3 to the 2nd power, x to the 3rd to the 2nd power, y to the 8th to the 2nd power. Whenever you have a whole number being taken to a power, you want to be able to put it in your calculator so you can get it as just the numerical answer here. 3 squared is really 3 times 3. That's why I'm getting 9. This is a power to a power problem. 3 times 2 gives me 6. 8 times 2 gives me 16. So my final answer to 3x to the 3rd, y to the 8th, all to the 2nd power is 9x to the 6th, y to the 16th. For part G, I can do this in a couple different orders. I think the easiest way to do it is resolve what's happening inside the parentheses first, and then worry about what's happening outside the parentheses. So what I can do first on the inside is I can see this as x to the 11th over x to the 8th. That means the x's are really going to resolve as 11 minus 8. 11 minus 8 would give me x to the third, which is on top. So that became x to the 11 minus 8. This y still stayed as y to the fifth, and this still stayed as negative 2 on bottom. All I did was take this x to the 8th that was on bottom, this x to the 11th that was on top, and apply the rule for division. This still is all being taken to the third power. 11 minus 8 gives me 3, so I get x to the third, y to the fifth, over negative 2. If it's all being taken to the third power, then I can see it as each individual part being taken to the third power. So it becomes x to the third, y to the fifth to the third, all over negative 2 to the third. These are using the power to a power rule. 3 times 3 gives me x to the 9th. 5 times 3 gives me y to the 15th. And then this negative 2 times 3 really means negative 2 times negative 2 times negative 2. If I put it in like this correctly with parentheses in my calculator, it'll give me the answer. Or I can see it as how to do it out mathematically. Negative 2 times negative 2 would give me 4, times another negative 2 would give me a final answer of negative 8 on bottom. When I said there were 2 different ways you could do it, you also could have done it by distributing this third power right from the start. That would give me x to the 33rd, y to the 15th, negative 8, and x to the 24th. X to the 33rd minus x to the 24th would give me the same x to the 9th, and the other parts of the problem would be the same. So either order would get you the same place. You kind of just want to think about which one is easier to do. So to me, it's easier to do this subtraction than to have to cube all 3 and then do the subtraction afterwards.